So welcome once more. Yesterday we discussed what memory management is in Rust, and we were able to understand how memory is managed in Rust. We understood the difference between stack and the heap. We understood the different types of data types that are being stored and how these different data types are being stored. We were able to differentiate the dynamically sized data type and where they are being stored. We were also able to talk about the static data size, that is, data types that have a fixed size that is known. And we understood from last class that all of these are stored on the stack. Then next, we moved on to talking about ownership. We were able to, in fact, understand what ownership is in the Rust programming, why it is important for the Rust programming language to make use of this ownership feature. We also went on to talk about references. We talked about immutable reference and mutable reference. We then went on to discuss the importance of referencing. We also spoke of rules that are related to referencing. We made mention that you cannot create two mutable references at the same time, but you can create so many immutable references at the same time. And we were able to understand the reason for all of this. So at the end of last class, a question was raised, and the question had to do with lifetime. And I made mention that this particular class, I would in fact be starting with the answer to that. I'm not sure Coxie is here. So I'll stop sharing my screen and rather share all of my screen to show the answer to that before we move on to what we'll be discussing today. So from this code from last class, I would remove all of this. Is there someone raising the hand? Okay, I've been struggling with structs. This is perfect. Okay, great. Great. This is definitely the class for you. So today we'll be discussing structs, but I want to just give the answer to the question that came up from last class. So the question was on lifetime. I would remove this. I would remove this. I would also remove this. I don't know if Coxie is on the call now. Yeah, I am. The question was raised that why do we have an error here when we are actually passing in a reference and then we are returning a reference? Why can this reference not just be returned just like that? That is exactly where lifetime come into place. I made mention that in today's class, I'm going to explain how that works. And here it is. For every single function, from last class, we explained that each function, whenever it takes in a variable, it automatically becomes the owner of that variable. But then, if the function takes in the variable, the parameter as a reference, in that particular case, it is referencing the variable. So it does not take ownership of the variable. But then, what happens when you are returning the same referenced variable? There is what we call lifetime. This is where lifetime comes in. And in fact, in today's class, it's in fact nice that I am talking about it now, because in today's class, we would also see how lifetime come into place when we are using structs in Rust. So to declare a lifetime, you would have to create this and add a in front of it. It's more like a generic. It's more like a generic, which is something we'll be learning in the future. So for this particular case, this particular parameter, the Rust programming does not know when the very parameter would be dropped, because it believes that all of the variables that is being passed in as a parameter to the function is owned. But now you are trying to reference a particular variable, and then you are not sure if that particular variable you are referencing, because if we call this function calculate length, inside this main, we have to pass in a particular variable in it. We are not sure if the variable lifetime would be cut short. That is, we are not sure if at a particular point in time, that variable would no longer exist. For this particular reason, we need to introduce what we call lifetime. And this is how we use the lifetime. So we have more like an apostrophe mark up there and then a. Then also here, for the variable you are returning, you also have it like this. And this is how you deal with lifetime. And so at this particular point, the program wants to take reference to this variable, and then it ensures that the variable is able to live long until the particular time when it is returned here. And that is exactly how lifetime works. So, Coxie, that's the answer to the question you asked when you're ending yesterday's class. Okay, you have a question.
Sorry, I just want to ask a question. So do you mean now that without lifetime that the variable won't live long until it gets returned? Is that what you're
Exactly,
trying to explain?
exactly the point. At this particular, remember we said Rust is a very typed language and it manages the memory very well. In this particular case, if we imagine, let me do it here. Imagine we declare the value as, let's call it t. I'll call it underscore t is equal to 6. Now, at this particular time, if we pass in t inside this function calculate length, let's call the function calculate length. Let's say it is s, and then yeah, we pass it in like this. At this particular time, oh, am I using t somewhere here? Oh yeah, this is meant to have an error. It's in a different scope. At this particular time, notice that there's an error. R, R is not initialized. Am I using R somewhere? Okay, I actually have plans of using C. Let's remove R. We don't need R. At this particular time, notice that T is being passed in here as a reference. It's a reference, and then it's being passed as a reference. It is getting into this function calculate length, and then it is returning it. But now, we are not sure T would live long enough to be returned when it goes through this function. If we remember part of the rules of ownership, the rule of ownership states that if a function is not referenced, immediately, if a parameter is not referenced and it is used in a function, the function automatically takes ownership of the variable. Now, in this particular case, we are referencing it. Now, we are referencing it and now returning it. So at this particular point, we cannot understand or define how long this particular variable is going to live before it is dropped. And for that reason, Rust introduced lifetime. So with lifetime, you can be sure that a particular variable would live long enough until it is returned. Now, in this particular case, if only we were not returning t, which is a reference to this particular underscore t, and we were just using t inside that function, at that particular point, t is not returned, then we can define the lifetime of t at that particular point, because we understand that the lifetime of t ends inside that function. Rather, it is not that after t is returned again, another function uses it. So because of that reason, we cannot determine the lifetime. So this particular syntax is used to express a variable or parameter in this case that it is returning it and it is serving as a lifetime. Does that make sense to you?
Yeah.
Okay. So having that in mind, we'll be going to what we are meant to discuss today, and that is understanding structs in Rust. So what exactly is struct? Struct is basically a custom data type, and it basically allows you to group different data types together. So these different data types can basically have different different types. What do I mean by this? A struct literally have opportunity for you to define the types in it to be different. If you remember from previous classes when we are talking about types, we understood that an array cannot take in different types. Rather, an array has just one type. Then we spoke about another data type, another compound data type like the tuple. Now, in the case of the tuple cannot be like the array. That is because the tuple has the opportunity to have different data types. And in this case, we can compare it to struct. So the struct has certain key features. One of the key features of struct is it has named field. Unlike tuple does not have named field. It's basically, you are basically grouping everything together in parentheses. Then you can either destructure it the way you like. Also, it can contain different types of data, just like I made mention of. And the most important reason or feature of a struct is it allows you to organize and manage related data effectively. And this is very important in Rust. In fact, in programming languages, because Rust is not the only programming language that makes use of structs. Other programming languages make use of a custom data type that allows you to group data. If you, since we are in the blockchain space and we are talking about um, smart contracts, if you're looking at Solidity, Solidity uses structs, and in Solidity, you can use these structs to basically group different data types. Also, other languages have their own way of grouping the data type. So it's important for as a building block for creating domain-specific types. It also enhances code readability and maintainability. So all of these things are key features and importance of struct. But what exactly does the struct look like? The struct has a struct syntax name. Then you have the name you are defining the struct. Then inside it, it has the fields. The fields are basically the elements you are passing into the struct. So it can be so many. It doesn't have a definite size. So notice from this example struct user, this particular example has name, email, sign-in count, active. Notice that these data types are completely different. So it basically allows you, as I've made mention of, to have a group data that with different data type. So that is one importance of structs. Also, to instantiate structs, just to be sure I'm together with everyone. Okay. To instantiate structs, we are going to look at it in code. So for all of this, I'm going to comment all of this. And then I would create a new main, a new main. And yeah, so good. So to create an instance, you basically create it and pass in the fields into it. The order of the field doesn't matter, but most importantly, all the fields must be initialized. Then the type of each field must match the struct definition. So we are going to try to create a particular struct now. For this struct, we will name it user data. User data. So for this user data, we want to know the user's name. For the name is literally a string. Now we want to know the user's age. Yes. The age is basically the data type I32. We want to know the user's marital status. Is he married? We want to know. What else do we want to know? We want to know the user's mail address. That's string. That's string. So this is how to define structs. So this is what a struct looks like. So now inside this particular struct, we can have the name, the age, the marriage status, the marital status, and the male. All of these can be for just one person. Now, how then do you use this? To use it, there are different ways to create or use a struct. And all of these different ways is what we'll be looking at in today's class. So I want to move along with the slides as I am practicalizing it on the code. So first of all, we will create the first one. We name it user1. For user1 to define it, you create the struct, user data. Then inside it, you have the name. Then define the string from, let's call the user Ayo. In fact, let's call it Ayomide. Then also for the age, what should we call the age? Let's say 40. Now, married. Let's say false. What is male? Is email. It is string. We create the string from, so we create this Adebara. Let's type this where ayomide@gmail.com. So, yeah. And this is basically how to create or use a struct. So in this particular case, I have basically grouped my own data by creating a user data for myself. And this is basically a good way to basically group a data, because with this now, this is user one data. Now I can still use this particular struct to create another data for someone else. In this case, we can say the name is Nomad. Age, we can say 3. Married, we can say false. Male, we can say string. We use string from, or just to make it short, I'm just going to make a shortcut and say nomad.at@gmail.com. And then I'll use to string. So this is just another way of creating a string. It's a string slice. I think I have made mention of this before on how to create a string size, and I use the method .toString to basically convert it to a string. So with just this one struct, we are able to create a data set for 2 different people. And this is how good or how important the struct is in the programming language, basically. So coming back, does anyone have any question up to this point before I proceed? Does anyone have any question at this point? Can everyone still hear me? Can I see a sign if everyone is still following me? Okay, okay. So that is basically how to create a struct. Now, part of the rule is that a particular struct must have all of the data field. So in this particular case, imagine we removed this. We are going to have a compiler error. What's the compiler error? Missing structure field. So for every structure, which is every struct, all of the struct field must be added. So everything must be defined. So no struct field must be left undefined. So this, I'll return it back, and then the compiler error is basically gone. So moving on, accessing and modifying struct fields. Accessing fields, use dot notation. So for example, if you use instance dot field, you can basically access all of the struct field by doing that. So let's practicalize that. To practicalize this, in this particular case, notice that I have not yet printed all of this data. And there's a reason why I have not printed it, because we are going to be introducing a particular macro. But then until we get to that point in the slide, I will not print all of it. So now let's say we want to access Dana's data. To access it, let's name it Dana's name. To access it, all you have to do is user2 dot name. And this is how you access this particular data from user2. So for this, I can basically print it out. And if I print it, I can say my name is, then I would add this and then add this. So at this particular point, if I can go run it, can you see? My name is Nomad. That is because we are basically using this data, that's the name, by using dots, that particular struct field. And that is basically how you access all of it. So imagine we want to use everything here. We can say my name is this. I am years old. And for that, we add the second one. We add. So you can basically create a new variable to do that, or you can basically use it here. So I can say user2 dot age, and that's it. Once I console cargo run, I have it. My name is Nomad. I am 3 years old. So you can basically access all of your data, all of your struct field by dotting it. So you say dot whatever field it is. Then next, modifying fields. If instance is mutable, you can modify it. If it is not, if it is immutable, you cannot modify it. So mutability applies to the entire struct, not individual field. So that means that, notice that for this particular struct we've created, it is immutable. So in this case, if I said user2, let's use user1 now. We've used user2 too much. User1 dot age is equal to 50. Now we are trying to mutate user1. What happens? We get a compiler error. What's the problem from the compiler error? Cannot mutate immutable variable user1. So to solve this problem, all we have to do is add the mute keyword. Adding the mute keyword basically, adding the mute keyword basically allows you to mutate these old field elements. So you cannot basically create a particular field or a particular struct and then try to use the struct without, like, try to modify the struct without adding the mute keyword. So that's basically that on that. So field init shorthand used when variable names match struct field names. So basically, we are going to experiment this. All this is trying to say is that whenever you have a function, you are creating a function to initialize a struct. What does that mean at all? In this particular case, notice that we are basically creating all of these structs manually. We came here and then we are creating them manually by creating the user data and then passing the user data, the age, the marital status, the mail, all of these things inside the field. Imagine we want to create it in a dynamic way. We can basically create it as a function. We can call it create user data. Create user data. So to do this, you can basically use different names of parameter, but it's nice if you actually use the name of the field element in the struct. Why is this so? This is because if you use the name, you can basically use it. I'm going to, in fact, do both examples. I'm going to show you how to use it if you don't use the name, and then if you use the name, the difference. So for this, I'm going to call it username. Okay, no. Yeah. I'm going to call it username. It's a string. Then for the next one, I'm going to call it user age. The next one, I'm going to call it user married, user male. And for this, we are going to return the user data. So for this, we are going to create the user data. Okay, let me pause this. So this is string. This is also string. Yeah. So for this, we are going to create the user data. And for the user data, to pass in the field, we will now create, we will going back to the struct. This is what the struct looks like. The name, the age, married and male. For this, we create name. Okay, name. Then we pass it as username. Then the age, we pass it as user age. Now, user married, we pass it as user married. And then for the last one, which is male, we pass it as user male. So doing this, we have been able to create a dynamic, a function that dynamically creates all of these structs. So this function basically creates new structs every time. So you can basically use this same function to create this user one struct and user two structs. So I'm going to do that. For this, I'm going to comment this out. Then I would call this user three. For user three, oh, I didn't declare it. So we say user three is equal to create user data. So for the user data, remember for the name, it's a string from, what's the name this time? We call it might. No, let's say might. Then for the user age, we say 26. Married, we say true. User male, it's a string, right? We say from might.com. So basically, we've been able to use this function to create another user. So with this function, you can basically use this function to keep creating more users based on this struct. But then, can we actually print our user 3? So to do that, I'm going to try to print the same data. My name is this. I am this. Years old. So with this, we can say user 3 dot name. And then for the other one, user 3 dot age. Then you can cargo run it. Notice my name is Might. I am 26 years old. So basically, you can get all of the user data and create dynamic user data by doing this. Notice, before I continue, I would like to see, is everyone still with me? Okay. Does anyone have questions at this point? Or I can proceed? Can I see a thumbs up to show everyone is following? Okay. 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 Thank you. So with this, you can basically create a data type dynamically. Notice that what I am returning here is the particular data type I'm meant to return. And in this case, we are returning a struct, and the struct is user data. So in this particular case, all I did was just to declare it and return it immediately. I returned it while declaring it. So that is why I did it like this. I can also declare it, make it a variable user, and then I return the user. You can basically do it this way too. Now, going back to our slide. In our slide, we made mention that we can basically use the same struct name to declare a struct when using it in a function. So I made mention that I was going to do it in two methods. The first method, which is not the friendly method, which I would not advise you to use, is this I have just done. That is having a different name from the struct name. Because basically, it is left to you. It's not wrong to do it this way, but it's always wise to make your code clean. So I'm going to do the other method. I'm going to do the other method. For that, I'll call it create user. For this create user, it's going to take in the exact same name of the fields, the field element, the exact same name. So for the first one, I'll name it user. It's a string. Second one, I would name it age. It's an I32 value. Third one, married. It's basically a Boolean. And the last one, male. It's basically a string. And this, I'm going to return the user data. So for this, to create this, all I have to do is user data. In fact, okay. Then all I have to do is user, age, married, and male. And this is all. Is there a problem? Let's see. Missing struct field. Is there a missing struct field? Oh, I named this user instead of name. Yeah. So there is no name. This is meant to be named. Okay. No one tried to correct me. Notice that. Okay, let me draw this down. Notice these two codes. The first one and the second one. Both of them literally does the same thing. They do the same thing, but the difference is that this is neater and cleaner. This is looking longer and rougher. So it's wise and better to write your code this way. So with this, you can basically call it here and it still basically does the same thing. And that is exactly what the slide is saying. It improves readability and reduces repetition, basically. Structs update syntax. So to create a new instance based on an existing, the syntax ... is used. What does this mean? This means that whenever you want to create a struct from an existing struct, all you have to do is use the ... syntax. In JavaScript, it's just all about that particular syntax is actually three. And is used to destructure a compound data. And this is exactly the same thing as this. So we are going to experiment that and do that here. What exactly does that mean? This means that imagine we want to create user 4. So let's create a new variable. We name it user 4. For user 4 as we are going to still use our normal this thing without using the function. User 4 as the same name. No, let's not use name. Let's say user 4 have a different name. Let's use a different name. Let's name user 4 Tobias. So we name user 4 Tobias. Now, Tobias is not married. He has a different mail. Let's add the mail. Now, for Tobias, we say his mail is tobias.com. Now, Tobias have a different name. He has a different mail, but Tobias is 3 years of age, and Tobias is also not married. So instead of creating all of these fields all over again, we can basically do something. We can use user2 struct. So for that, all we have to do is use ... user2. With this, we are able to basically create all of what is needed in the struct field, and then we are able to reuse another struct. So there is no need to type again that user 4 is age 3, user 4 is not married. Instead, we can basically destructure all of this remaining data from user 2 and use it for user 4. And that is exactly what this ... sign is used for. So you can use it to destructure or you reuse an already initialized struct and use it on a new struct you are just creating. Also notice that the name, the mail, they are not coming in a accordingly. They are not coming according to how I defined it here. Notice it's not coming according to that. The name is first, the mail is the last, but notice that I'm using it anyhow. That means that in the struct field, it doesn't matter how you arrange them. So basically, so it's useful for creating instances with minor differences, and that's what we have just explained. We have the tuple struct. The tuple struct is basically a type of struct without name fields, just like types. So we are going to be demonstrating it. In this example, it creates black color 000. It's more like RGB. Origin point 000. a point can have 3 points, and you can basically use the struct to do that. So struct is so powerful, you can use it to group any data type. And we're going to create another example of a new struct. Let's come down and do that here. So we are going to create the struct and name it colors. We would actually colors, and these colors we use I32, I32, I32. So this is basically a different way. Notice that this particular struct does not have fields like this one. It doesn't have name fields like this one. Rather, it's a kind of struct that is combined with a tuple. So to do this, we can create a new field for this by doing this. So if you come to main, come down, we say let's color1 equals, what did we name it? Colors. Oh, colors. And then we say 23, 43, 12. And this is basically how we use it. So for this, you can have this initialized and then you use it to create so many. We can create this and name it color2. Imagine color2 having different numbers and on and on and on like that. So you can basically use a struct that is combined with a tuple. So this is basically how to use it. I'll come back to the class now and ask if there are any questions at this point. Do we still have any questions at this point, or everyone is good to go?
So please can you explain this tuple struct again? I didn't get it.
Okay. So now, coming back to the original struct. For the original struct, it has the fields with different types, and the fields are basically named. But rather, for a tuple struct basically, what is a tuple? A tuple is just a group of data that is grouped together using parentheses. So let me create a simple tuple without a tuple struct. Coming back to, let's call it simple tuple. Doing this, 23, 45, 60, 76. This is a simple tuple. A simple tuple is a group of data. It can in fact be more. It doesn't have to be 3. It can be more. We explained it in previous class. A simple tuple, group of data that is grouped together with parentheses, basically. Now, in this case, we are now saying we can create a struct tuple. So this is how to create a struct tuple. For example, we are naming this struct tuple colors. So for this, we use the syntax name struct, then the name of the struct, and then we add a tuple in front of it. And then for that, to now use this tuple, we basically call colors and then add the tuples in front of it. And it's as simple as that. Is that gotten?
Yeah.
Okay. So moving on.
So tuple struct is mostly for numbers.
No, no. I made mention that tuples, if you remember from our previous class, when I talked about tuples, I made mention that tuples can basically have different data types in it. So now,
The same.
let's now go back to our tuple here. No, before that, let's go back to our tuple here. This particular tuple can have a Boolean, it can have a string, So it can have all of these. Notice that the type is in front of it here, I32. The first is an I32. The second one is a Boolean, and the last one is a string. So it's just like that. You can basically have different data types in it. And that same applies to this. For this, if I change this, notice that there will be a compiler error since I'm using it somewhere. I can change this to string. Change this to string. And change this to Boolean. As I made mention, there will be errors there. For this to string, I can basically redeclare it as a string and basically add might. And all of the former rules just apply to it. The last one is a what? Is a Boolean. Let's call it say false. And then we can duplicate this, remove this, and that's it. So a tuple can basically have different data type. Is that gotten?
Yeah. So one question, sorry.
Okay.
Um why use, like, I don't know if the right question to ask, but why use tuple struct when you can just use the normal struct? Like what's the reason one should use a tuple struct? There is
Now
particular reason why.
that's a great question. Uh, this is because you have different use for your implementation. Now, remember when I was, in fact, introducing the tuple struct, I made mention that you might want to have an implementation that has to do with defining colors. Imagine you are building an application, and what the application does is, once you click on the color, it basically returns the color number. I don't know if you are familiar with front end, how color is being defined using the RGB in CSS. So you might want to create an application, and all you want to do is you want to use a struct that returns the colors by number. And for the color that has 3 digits for 3 different data for the numbers, you can basically use this particular color struct and it would work well. This one has a different data type. Let's imagine this was I32. Okay, I32. This was also I32. Let's remove this. I know there will be a compiler error since we are using it differently here. So the use case permits you to use it this way. Would you rather want to use a struct with, let's call this a struct and call it colors. Let's call it color. Would you rather want to use this struct with color 1? Then name it color 1, I32. This is just let me add 1 here. This is just a typical example to answer your question. Color 2, I32. Color 3, I32. So now, in this case, which of these implementation fits the description of the task I made mention of earlier? Is it this
Um,
implementation or this implementation? Which one?
the tuple struct.
Exactly. Can you see? So there are different implementations with different uses for the different data type. One of the important reasons why, what?
Continue.
Okay. One of the important reasons why we are even talking about structs in the first place is because it allows us to group data. Now, you might want to have grouping of data in a different way. So it might group it in a tuple way. It might group it with having field elements like these. So it's based on whatever you want to use it for. So that's that for that. Now, going
How
on,
about Enum?
we are still coming to that. The class for today is
Okay.
basically designed for struct. We are still going
Okay.
to have a class on enum. Don't worry about that. Hmm? Okay, I think there's a question. Emmanuel.
Okay. Hello, can you hear me?
Yeah, I can hear you.
Yeah. Okay. I was having some network issues, so I missed out on a couple of things you said, and I don't want. Oh, okay. Previous classes on. Okay, yeah, that's what I wanted to ask. I wanted to see if I could access.
Okay, okay. Yeah, you can get access to the videos for all classes. All the classes are always uploaded to um, YouTube, and you can basically get the link on the Notion. So Nomad will basically give you access to that. Okay, so moving on, unit-like structs. What are unit-like structs? Just like the name, unit. It's basically a struct with no field. So a particular struct that doesn't have any field. Let's make use of an example of this. Um, let's call the struct genders. This is a unit-like struct. This particular unit-like struct basically does not have tuples or field elements. It's just one, just like the name defines. But what exactly is this type of struct used for? It is used for implementing traits without storing data. That is one use case. Now, you can use it for different things, just like I've made mention of the tuple example that we spoke about previously. You can use it for different use cases. But some of the use cases that are quite familiar with using a unit-like struct, because you might wonder, why would you want to use a struct when it doesn't even have any field elements for you to even group any data? One of the uses is implementing a trait without storing the data. Another use is creating types for type level programming. And this is an example that I've made mention of. So as time goes on, when you start using some kind of complicated traits, then if you look at the documentation, you then see some of these particular unit structs that are being used for it and how these unit structs are being used for it. There might be example in the future whereby we might be implementing something, and what we would then be using at that time would be a unit struct. Ownership of struct data. If you can remember, while I was trying to explain references at the beginning of this class, when I was talking about lifetime, remember that I made mention that we were going to talk about this during the course of the lecture, and here it is. Now, just like a function particularly talking about the lifetime when it comes to function, it has the mark sign and a to define that it's a lifetime that is happening. Whenever you are talking about something like this, it also applies to structs. How? This is because struct is used for grouping data. That is, a particular struct, like we've made mention of here, can have its own data like this. All of this, they can have their own data. But then this particular data might be passed from one particular scope to another. And at this point, it might be referenced. And you are not sure that what you are referencing is a what? Is a variable that is still valid. So a variable might not be valid. And at that particular point, when you are doing this, you have to make use of what we call lifetimes. And this is the syntax that I've made mention of. In this particular example you are looking at, the struct basically makes use of this lifetime because it is using a string slice. What is a string slice? A string slice is basically, it's just like the name, a slice of a string. So a string slice from previous class, we have explained that it's a data type that is sized. So it is not a data type that is stored on the heap. Referencing last class, it is a data type that is stored on the stack. This is because it has a fixed size and it is not dynamically sized. And for this kind of data, if you remember from the last class, we were able to say that because dynamically sized data types are placed on the heap, I spoke of how a particular variable is able to reference where the data is stored on the heap. So it is easy for different data, different variables to point to the same data that is referenced to the heap. But now in this particular case, when talking about slices, it is not on the heap. So it is basically on the stack. And when we were talking about stack, we are talking about first in, first last out type of situation. And so it's not easy to easily point to that data, and the data can basically be lost at that point. And that is exactly why it is important to use lifetime. So lifetime is basically what you use when you are not sure of the data lifespan. So when you are not sure when whether a data will last. In fact, interestingly, the Rust programming language, we use the compiler to tell you, bros, your data cannot, we are not sure when your data will become invalid. So to know when your data will still be used, it is important that you implement the lifetime. This is where we are going to be stopping for today's class. I don't know if there's any question based on everything we have discussed today. Are there any questions from anybody? At this particular point, I'll stop the recording.